Hey boys and girls, so today we're going to be going over the Unit 12 review. I hope you're just as excited as I am because after this you have one more unit to learn and then we are done for the year. So let's just jump right in here. So as I read number 1, it says given, and they're giving me all these values. G is represented by this value. A is here, M is here, right? E is here. So they're giving me all of those values. And it says, which of the following would result in an irrational number? All right, so I'm just going to go ahead and box this. If you remember from when we had gone over lesson 1, what a rational number is, irrational numbers, things like that. I know that an irrational number, you guys got it, cannot be turned into a fraction. So cannot be written as a fraction. Okay, I know that a shortcut is for us to remember that if someone, in real life, a person is being irrational, they're not making sense, they're being crazy. So it's also a hint when you're looking at a number on the calculator. If it's irrational, just kind of how it looks. But mathematically, this is how we know if it's an irrational number. It can't be written as a fraction. So I just went ahead and I rewrote all of these values. Instead of writing A plus E, I'm writing what A represents and what E represents, right? The square root of 4 plus the square root of 100. So whenever it's multiple choice, I always like to write my choices out, just so it's clear as day what I'm working with. And then I have the calculator, so I might as well use it and plug those in. So here we go. I'm just going to type that in for us. So if I do the square root of 4, arrow out, plus the square root of 100, and I press enter, I'm just typing in what they're giving me, I get the whole number 12, all right? So I'm gonna go ahead and just write that on my paper. Then I'm gonna go to number 2, and I'm gonna type that in. So it's the square root of 50, arrow out, plus the square root of 100, enter. And already this one looks kind of crazy, so I'm thinking maybe it's irrational. So let me just check, can it be written as a fraction? So I'm gonna do math. And then I'm gonna just check that first choice that says frac for fraction, enter, and it seems as if it cannot be written as a fraction. So if it can't, that means it's irrational, and that's what I was looking for, so I know number 2 would be my answer. Okay, number 1, that whole number 12, is cool, calm, it's collected, it doesn't look crazy, and I can write 12 as a fraction because if you remember back to lesson 1, I know that any whole number can be placed over 1. All right, so I can write it as a fraction. But just to make sure, I'm going to check choices 3 and 4 as well, just to make sure I didn't make any mistakes. So if I do the square root of 81 plus the square root of 4, press enter, I get the whole number 11. And again, I can place 11 over 1. So that is written as a fraction. I'm looking for what not is a fraction, okay? So now I have the square root of 81 and then plus the square root of 100. And then again, I'm getting the whole number 19. And again, 19 can be placed over 1, so I know it is rational. All right, number 2. It says, which statement is not always true? So I'm going to go ahead and just box the word not. I know a lot of us, including me, right, can sometimes skip that key word because we're so busy looking for what is the answer. So just be careful. Okay, these are the rules that we had gone over in lesson 1. I'm going to just add that onto the top here. It's from lesson 1. And they have to be memorized, okay? None of this is given to you on the Regents. It won't be given on a test or a quiz, so you have to have that memorized. So the way I try to remember it is if I'm being rational, someone else is being rational, right? We're all being rational. We got a rational conversation going on. And then the R and the I, right? If I'm being rational and you're being crazy, usually crazy wins, right? Because you can't work with crazy. So R and I always gives you an I, okay? So if you can remember even just the first 2 here, then you can remember the third one almost like by default. So 2 irrationals. So if 2 people are being crazy, sometimes the answer is crazy, all right? You just get a crazy person. But sometimes 2 crazies come together and then they get that rational answer in the end, okay? So again, this has to be memorized. Please make an index card. You guys can go on Quizlet, do what you gotta do to memorize those rules, all right? So as I look at the first choice, oh, and again, this is for multiplying or adding, okay? So this is all rules just put together. So if I have a rational and an irrational, they're saying that the answer should be irrational. Well, let me check. R and I R and I gives me an I. And that's what choice 1 says. Choice 1 is true. I'm looking for what's not true. So as I look at number 2, it says the product of two rationals. So I have two R's, two rationals. Well, two rationals is always rational. And that was the answer. It's saying it should be rational. So again, 2 is true. I'm looking for what's not true. So I know it's got to be 3 or 4. So let me keep going. Choice 3. If I add two irrationals, so I have two I's. Well, two I's can either be an I or it could be an R. Depends on the situation. This choice is saying the two I's is always rational, but that's not true. Sometimes it's rational, sometimes it's irrational. And I'm looking for what's not true, so it's choice 3. And just to double check, if I look at 4, it says rational and irrational, so R and I should give me an I, and that's what the choice is telling me. It should be I. So again, that's true. I was looking for what's not true, which is choice 3. All right, number 3. It says, given the graph of the line that's represented by that equation, g of x equals 3x plus a. If a is decreased by 3, the graph of the new line is shifted 3 units where? Is it going up, down, left, or right? So as soon as I see the keyword decreased, I'm hoping you guys are thinking this as well. That means to subtract. So if I'm subtracting 3, I'm going to just create my own example here so I can clearly see what's happening. All right. So I'm just going to rewrite g of x equals 3x. And I'm just going to give a value, all right? And you can always do this, guys. If you're unsure of what the answer is, because unfortunately, you'll only know this by memorization, you can always create your own example. So I'm going to let a be represented by, I don't know, let's do the number 5. So plus 5, okay? The question says if a is decreased by 3. Well, originally, my a value was a positive 5. If I want to decrease this 5 by 3, well, 5 minus 3 is 2. So now I have g of x equals 3x plus 2, okay? And if you have a calculator, you know, if we were in school, you guys would have those on your desk. So then you can say, all right, well, I'm just going to jump over to my calculator and just easily figure out what is happening here. So I would go to y equal, and I'm going to type in my first graph, which was 3x plus 5, okay, because I just made that up here. And it's going to graph for you in blue. All right, so you see there's my blue line. That's the original function. Underneath, in red, now I'm going to graph my new function, which was 3x plus 2, because I decreased it by 3. All right, now I'm going to press graph again. Well, I can see that I'm moving from blue to red. It looks like by moving down. I didn't go up. It's not going to the left. It's not going to the right. It's going down. All right. And I know it's going down because I can always look just right where it's hitting on my graph. It's not hitting the y value of 5. Now it's hitting the y value of 3. All right. So I know I'm definitely moving down. All right. And you can always look at your second graph. Look at those tables. And just actually look at the values. I'm moving from 5 to 3, down 3. 8 to 5, down 3. Okay, so on and so forth. So again, this would have been down 3 units, which is choice 4. And you only have to use this method if you don't have the rules memorized, okay, off the top of your head. Since I know this minus 3 was outside the parentheses, that moves me up or down. All right, and it would have been the down 3, okay? And then if I look at number 4, very similar to how we solved number 3, they're giving me the graph. I can easily just type this into my calculator to see what it's gonna look like, okay? So I'm just gonna go ahead and jump right back over. So I'm gonna go to y equals, it's the square root, of x, and then scroll out, minus 1, okay, because that minus 1 is on the outside. If I go and look at my graph, I can see it's like a little R shaped almost. It's like a big little swoop to the right. So now I'm going to go back to my paper and I'm going to see which one matches. It didn't look like a V or a U or a line. It looked like that curved almost like an R, like to the right hand side. All right, so I know it was choice 2. Moving on to number 5. So here, if I look at number 5, it says the graph of y equals ax squared is shown below. If a is multiplied by 3, what happens to my new graph? Okay, I'm going to solve number 5 the way I did number 3. So again, if you don't have the rules memorized, you can always create your own example. So right now, a is a variable. I'm going to plug in a number and just make up my own example. So let's say I let a equal 1, okay? That means this function that I'm starting with, it's not going to be y equals ax squared, it's going to be 1x squared, okay? And I'm just picking 1 because it's an easy number to start with. The question says if a is multiplied by 3. Well, if a is 1, what's 1 times 3? Exactly, it's 3. So I'm moving from y equals 1x squared to y equals 3x squared. And then it says the graph of the new equation is what? Is it wider? Is it narrower? Did it move up? Did it move down? You know, we don't really know right now. So I'm going to go ahead and again, just jump back to my calculator here. I'm going to go to y equal. And I'm just going to type in 1x squared in the blue. I'm going to see what it looks like. Okay, it starts at 0, 0. It looks like a happy face. Okay, and then underneath in red, I'm going to graph that new function, which was 3x squared. So I'm starting with blue, going to red. Let's see what happened. All right, so if I'm going from blue to red, they're both still starting at 0, 0. So it doesn't look like I moved up or down. So I'm going to cross out choices 3 and 4. That means it has to be 1 or 2. Again, I'm moving from blue to red. It looks like I was wide and now I'm a little bit more narrow. So I know my answer has to be choice 2. It was more narrow. And then this is again from the notes. So if that a value is greater than 1, you get a narrow function. And if that a value is less than 1, you get a wider function. All right, so these are the notes that you can memorize, but if you didn't have them, you can always make up your own example like I did. All right, if we look at number 6, it says the graph of y equals f of x is shown below. So here it is. What is the graph of y equals f of x minus 1 and then the plus 2? All right, so here's another one. This one you wouldn't be able to solve at all without having the rules memorized. Because if you look at number 5, I knew that the equation was x squared, right? That function that I was graphing. It just says f of x. I don't know what f of x is. Same thing down here. I don't know what it is to try to graph it and see what happened. So these are the rules that you have to memorize. So I'm just going to put a little cloud around them. All right, so if I'm inside parentheses, that's going to move me left or right, and I should be thinking of the opposite sign. So if I'm inside parentheses, like that -1, I know that's moving me to the left or the right, and I have to think of the opposite sign. So I'm not moving to the left one, I'm actually moving to the right one. And then if there's no parentheses, like the 2 has no parentheses around it, that's going to move me up or down. And then again, I keep that sign. So if it says +2, I know that's really going to be up 2. All right. And now if I want to come up with my final answer, I always like to pick the first point that was plotted. Okay. So the first point that was plotted was over here. It was -2, +1. So I'm going to take this point and I'm going to move it to the right one shift, one unit, and then I'm going to go up 2 units. So from here, I'm going to go to the right 1 and up 2. 1, 2, and I'm going to plot that new point. Okay, this is the point -1, 3, and I know that's where my graph is going to now start. And now I'm going to check my choices. So the first point that was plotted here, it's not -1, 3, so I know that's not my answer. If I look at number 2, -1, 3, Again, it's not even plotted, so it's not 2. If I look at choice 3, -1, 3, it's not even plotted, and even if it was, it's not starting at that value, so it's not 3. So it should be choice 4, -1, +3. The point is plotted, and it's where I'm starting. It's that first point, so I know choice 4 is my answer. All right, if we look at number 7, it says if the original function k of x equals 1/3 x squared, and they're telling you it's shifted down 5 units to make the function m of x, which expression would represent m of x? Okay, well, I'm starting with the k, and I need to make my way to m. So here's my original function. It was 1/3 x squared. If I'm shifting 5 units down, if I just look at the notes that I wrote up top here, well, if I'm moving up or down, there should be no parentheses around that number, and I'm literally going to keep the sign. I'm writing what it says. So this 5 gets no parentheses, and I'm going to write -5 because it says down 5. I keep the sign, so -5. So again, this should be on the outside with no parentheses. What choice matches? Well, not 1 or 2, because those have the 5 inside parentheses. Has to be choice 3, because I'm looking for a -5, not a +5. Number 8, it says, which of the following is rational? So if something is rational, just as a refresher, that means that it can be written as a fraction. All right, so I'm just going to jump over to my calculator here and type those values in and see which one can be written as a fraction. So if I look at the first choice, which is the square root of 80, I'm just going to type that in, square root of 80, enter. So I get that decimal, but that's okay. I'm going to press math, fraction, enter. It cannot be written as a fraction, so I know choice 1 is not my answer. If I look at number 2, I can't necessarily type this big decimal into the calculator because it has these dots on the end, which tells me it's just going to keep going and going, right? So I have to use my other rules. Well, if something is rational, it's calm, it's cool, it's collected, it terminates, or it repeats, okay? This is not terminating, and it's not repeating. It's just going on forever, and there's nothing, too special about it. So I know choice 2 would actually be irrational as well, and that's not what I'm looking for. So it's got to be choice 3 or 4. The answer would be choice 3, because this 11.11 is a really nice value, right? It's calm, it's cool, it's collected, it terminates, it's just 11.11. It's not crazy like choice 2, doesn't go on forever, so it would be choice 3, okay? If I wanted to try choice 4, the square root of 10, oh my gosh, we're back. Square root of 10, and I type that in, I get that decimal, but that's okay. If I press math fraction, I'm just going to check if it can be written as a fraction, and it can't. All right, so I know that I'm good. Moving on to number 9. So as I look here at number 9, it says, Becca stated that the sum of the expression 2.5 plus the square root of 25 is rational. Do you agree with Becca? Explain. Okay, so she's saying that this expression is going to be rational. Okay, another example of rational means it can be written as a fraction. Be written as a fraction. And then something so important, boys and girls, the question says, do you agree with Becca? So if you're going to answer this question, the first thing you're going to write is, yes, I agree. No, I don't agree. You're not going to write what this answer is. You're not going to write rational. You're not going to write irrational. You're going to say, yes, I agree with Becca, or no, I don't agree with Becca. Okay, and then you have to explain how you got your answer. All right, so we have to decide, is Becca correct or is she incorrect? Well, those are numbers. I have a calculator, so I'm absolutely going to type those bad boys in. So here I go. I have 2.5, 2.5 plus the square root of 25, enter, and I get 7.5. So I'm just going to check, can that be written as a fraction? Math, fraction, enter. And it absolutely can. So this value comes out to be 15 over 2, which is a fraction. So this is a rational answer. Becca said it is rational, and it was. So do you agree with Becca? Yes. Yes, I agree with Becca. And then it says to explain. So we're agreeing with her because the solution, right, our answer can be written as a fraction. Awesome. All right, here we go, number 10. Consider the graph y equals x squared. Explain how that graph y equals x squared plus 7 has changed from the original, which was just y equals x squared. So originally we had y equals x squared, but now it's changed because we have that plus 7 added on to the end. Again, if you remember the rules that we learned, if there's no parentheses, because there are none around the 7, it moves you up or down and you keep the sign. So this is moving me, it looks like up 7 units. So how is the graph moving? It's shifting, or it's moving 7 units up. And then underneath, explain how the graph is moving now. If the x plus 4 squared was originally x squared as well. So originally we had the x squared, now we have x plus 4 squared. All right, that plus 4 was added on. It's inside the parentheses, right? The plus 4 is inside. So that's going to move me left or right, and I use the opposite sign. So it's not going to move me to the right 4 units. I'm actually shifting 4 units to the left. All right. And you don't really have to memorize the rules for number 10. It's good if you have them memorized. But again, I know what the function is. X squared, I can type into my calculator. X squared plus 7, I can type those in. All right, so you can physically see what's happening from the start to the end to answer the question. Again, you can type this in from start to end and see what's happening. And you would have seen with the plus 7, it went up. And with the plus 4 inside parentheses, it actually went to the left. Okay, number 11. It says Jim is asked to transform the graph of AX shown below. The graph of AX is transformed using the equation. So instead of writing A of X, because that's this graph, I'm changing it to R of X, which means I'm taking the AX, that graph that was originally here, and I'm moving it around. I'm changing it somehow. They want you to describe how the graph is changed. Okay, so what's happening here? Well, for something like 11, I don't know what the function originally was. I know what it looks like, but I don't know what it was to type into my calculator. Number 10, I knew what it was. That was nice. I could have used a calculator for 10. 11, there's no function. So I have to have the rules memorized. All right? If I'm inside parentheses, inside, left or right, opposite sign. So inside means I'm going to the left 1 unit. All right, because I'm going the opposite sign. And then the -6 has no parentheses around it. That's up or down, and I keep the sign. It's that same sign. So if it says -6, that means I'm going down 6. All right, so how is it moving? We're shifting left 1 unit and then down 6 units. And that's it. All right, boys and girls, looking at number 12, our last question. So it says, on the set of axes below, they want us to graph g of x, which is radical x plus 5, okay? Or it's that square root function, the square root of x plus 5. All right, it's 2 different ways saying the same thing. So if I want to graph, like we always do, we always jump to our calculator, and then we look at the table for those x, y values. So that's what I'm going to do. So I'm going to jump over here. I'm going to go to y equal, and then I'm going to type in, it's the square root of x plus 5. All right. And I'm just going to press graph at first to see what it looks like. So if this is my origin right here in the middle, I can see that I'm not starting at 0, 0. It looks like it's starting at like -5, 0. And then it looks like it's just going up and over to the right forever. All right. Because if I scroll over, it's there, it's there, it's going, 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 right? Forever. So now I'm going to just X out of this. And I am going to go to my table. I'm going to press second graph to look at my XY values. So I saw that it started when X was -5, and it definitely did, because when X is -5, the Y value is 0. All right. And if I look at those values from before, none of these were plotted on the graph. And it has this little value, NA. On your school calculator, it would actually say the word error. And again, we went over that. It would say error because those values don't exist. If I were to plug in when x is -6 to this function, I would get an answer that's not real. It doesn't exist for that graph. All right, so I'm going to start my XY table with that -5, 0, since that does exist. All right, so we have -5, 0, and then after, I can see my next value is -4, 1, so I'm going to add that next. And then if you continue looking here, I can see that when x is -3, I have this big decimal. We're never going to plot decimals, boys and girls. We've gone over that in class before. All right, so I'm going to skip -3 and -2. The next value I'll add is -1, 2. All right, so we got -1, 2. And then I'm going to scroll to just see if there's any other values that I can add. Those are all decimals. We don't want those. Oh, and then we have 4, 3. So 4, 3 is a nice value. Let's add it. If you keep scrolling, the next really nice value is when x is 11. So I could add that to my table, but when x is 11, this graph isn't big enough to plot that. So I'm going to just leave it off. All right, so here we go. I'm going to plot the point -5, 0. So it's to the left 5, 1, 2, 3, 4, 5, 0. -4, 1, to the left 4, up 1. -1, 2, and 4, 3. Okay? And this is the most important part. On the Regents, this is a 2-point question, just the graphing. So many students get 1 out of 2 points. And you're going to be mind blown when I tell you why. This is all you should have graphed. Do you know what kids do on the Regents? I'll tell you. They add an arrow on the left-hand side as well, which is a huge no-no. Because if I press graph one more time, be really careful, there's no graph down here. It doesn't go down at all. It's only going up and to the right forever. All right, so just be super careful. Okay. And now underneath, these are where my rules would have to be memorized on the side here for you to answer this question. Okay? So it says if p of x equals g of x plus 4, how is it translating? How is it shifting? What's happening? Well, this was my original function, and this is what they want that new function to look like. Well, I know if I'm inside parentheses, I'm moving to the left or right with the opposite sign. So this isn't going to the right 4, it's actually shifting, or it's moving 4 units to the left. So it's moving to the left 4. If I look underneath, that plus 3 is on the outside. So if there's no parentheses, it's up or down, and you use the same sign. So if it says plus 3, that means I'm shifting up 3. All right, and that was it.